All right, so just a couple of reminders of steps that we want to go through when we're writing out, balancing, okay, a chemical reaction. If we're given a chemical reaction in formula form already, then we're going to be asked to write it out in words, okay? So obviously to write the proper names, we have to identify whether compounds are ionic or molecular, okay, so that we write the names correctly. So if we're looking at this first one here, okay, I've got copper with fluorine, okay, ionic or molecular? Ionic, okay? Does copper have more than one possible charge? Okay, so what am I going to need to put in this name? Right, a Roman numeral, okay? And that Roman numeral is going to be 2 because every fluorine is -1 and there's 2 of them, okay? So we're going to need a copper with a 2+ charge here. So we got copper 2 fluoride is reacting with sodium, okay? And that's going to produce sodium what? Sodium fluoride, again an ionic compound. That one doesn't need Roman numerals. Okay, how do we know it needs Roman numerals or not? If it's got more than one possible charge, you look on your periodic table where the charges are, top right-hand corner. Okay, if there's more than one number listed there, then you got to put a Roman numeral. Okay, and the thing that's going to be by itself is copper. Now, when copper is by itself, does it need a Roman numeral? No, it doesn't. Okay, it doesn't have a charge when it's by itself. Okay, only has a charge when it's an ion. Okay, and then we got to look at our balancing. Okay, if it's not a combustion reaction, because combustion reactions have their own set of rules, okay, then we pick the largest number and then balance from there. Largest number is fluorine with 2. Okay, there's 2 fluorines on the reactant side, and there's only 1 over here on the product side, so what needs to go in front of sodium fluoride? Okay, a 2, that gives me 2 sodiums, so I need to go over here and put a 2 there, and now everything is balanced. Okay, is that ringing a bell? What kind of reaction is that? Single replacement. Okay, all right, if we have reactions where it's written out in words, okay, remember we said these are a little tougher, okay, not because they're much different, but because we got more things to remember when we're writing out the reaction in formula form than when we're writing it out in words. Okay, we got to make sure we get our compounds swapped and dropped correctly. We got to make sure we look for special elements, okay, so that we put 2s or 8s or 4s or whatever they need on them, okay, so that we get the balancing right. Right, so we've got for number 9 here, magnesium, so that's Mg, okay, is reacting with nitrogen gas. Is nitrogen one of our special elements? Yes, it is, and it comes as a 2. All right, and that's going to produce magnesium nitride. Okay, what kind of compound is that? Oh, it's a synthesis reaction. Yes, sorry. What kind of it's an ionic compound here. So what do I have to do with it? I have to swap and drop. Magnesium is a 2+, nitrogen is a -3. So I take the 3 and I put it here, take the 2 and I put it there. All right, that's crucial. If I don't do that right, there's no way I'll get this reaction balanced right. Okay, now, biggest number in this reaction is magnesium with a 3. Okay, nitrogen's already balanced, okay, as a 2. So I just got to go back here and put what in front of magnesium? 3. Okay, why would I not do this? Because I see this sometimes. Exactly. Magnesium's not a special element. What you're saying when you write that is that these 3 magnesium atoms chemically bonded to each other. Metals don't do that. Okay? In fact, only the special ones that we have highlighted on our periodic tables do that, the molecular elements. Okay? This is not a molecular element, okay? So I can't write it that way. I know a lot of people would argue that, well, it's balanced, Coderre. Yes, it is, with an imaginary thing. Okay? That stuff doesn't exist. 3 magnesium atoms all alone, okay, are separate, does exist. Okay? Everyone follow me on that one? Right. And then we would, so it's balanced now, and we said that it's a synthesis reaction. Okay? Questions? Are there any from the first sheet that are giving you trouble that you'd like to go over? So you can just flip back to that first sheet, okay, the one that looked like this. Oh, then I think it's already in the the drawer labeled Science 10 Chemistry and Biology handouts. It's 2 pages, I think, or 3 pages. 2. Yeah. Okay. Any on there that are giving us trouble? No? Okay. Remember that the key for these is on my website. Okay. So you can check them as you go. Just make sure that you're doing them right, and then if you have questions, just ask. Today is going to be one of those days where if you got problems or you're not understanding something, definitely take advantage. Okay, ask in class. Yeah, if you finish all the worksheets, including the one you just got, in class today, which will be a challenge because it's a short class, then yes, I would allow you to do that. Okay, so in Science 10 stuff here, guys, on my website is where you go, and then look in chemistry, and it's near the bottom, I think, and it's called Keys to All Reaction Worksheets, right here. Keys to All Reaction Worksheets. Okay, we had it on the board the other day, I think. Right, and it's got the solutions on there. Okay, you can check it on your phone, or if you can't get it open, you can come up here and find what you need. Okay. Just want to go over number 8 here, okay, on the first sheet. It's a tricky balance, okay, and something happens on that happens once in a while. You need to be aware of it. You need to know what to do when this does happen, okay. So first off, okay, it's kind of a synthesis reaction, okay. We said that sometimes in a synthesis reaction you can have a compound and an element go together to form one thing, okay. It's rare, but in this case, the balancing is tricky because on this side, there's how many oxygens? 3. How many are over here? 4. There's 2 here, and there's another 2 over here. And that's the tricky part of it. Oxygen's in all 3 places. Okay? So I've got 4 on the reactant side. I've got 3 over here. What's the lowest common multiple of 4 and 3? 12. Okay? So let's go with that. Okay? We'll start out with trying to make 12 oxygens on both sides. So I'm going to start over here by multiplying SO3 by 4 and getting my 12 oxygens over there. When I do that, how many sulfur do I have now? 4. Okay, so I'm going to go back over here and put a 4 in front of SO2. Now, I know I've got to have 12 oxygens over here, okay, on the reactant side because I got 12 over here. Okay, so I've got 4 times 2 is 8. That's plus 2 is 10. Doesn't work. Can I put a 2 here? Now do I have 12? Okay, it's balanced, but it's not correctly balanced because 4, 2, and 4 can be reduced. It always needs to be in the lowest terms. So once in a while, you'll balance something with bigger numbers than you needed. Okay? And we always reduce them down to the lowest common, or to the lowest form. Okay? In this case, I can divide everything by 2 and end up with 2, 1, 2, and still have it be balanced. Okay? So on this side, there's 4, 6, and over here there's 6. Okay, so it works. Everybody follow me on that? It's not going to happen often, but once in a while, you'll look at your reaction and go, that's too big. I can reduce all of those numbers, or I can divide all of those numbers by something. Okay? Question, Nicole? No? Okay, guys, sorry, another one that's just come up here that often gives people trouble, okay, is G on the balancing sheet here, okay? So we're looking at hydrogen chloride reacting with calcium hydroxide to produce calcium chloride and water, okay? The trick to this one, what makes it difficult to balance is the way water is written, okay? I've got H and OH on this side, but I've got H and O on this side, and it can be confusing, okay, unless you change the way water is written to this. Because now it's going to be easier to track where the OH went, okay, during the reaction. So if you ever see a situation like this where you've got OH on one side in a compound and water on the other side, change the water to HOH. Okay? It's usually going to be a replacement reaction where you're going to do that. In a combustion reaction, you don't need to change the way you write water. H2O is easier in that case to track. Okay, but in an ionic reaction, okay, single replacement or double replacement, it's usually easier to write water as HOH. Nope, the 2's not going to go away. I've got, but that, yeah, because Right. And that's what makes it confusing, right? So what I'm going to do is now say, all right, there's 2 hydroxides here. How many are there over here? 1. So I'm going to put a 2 there, which gives me now 2 hydrogen atoms. Okay, not including the one there. Okay, so I'm going to go over here now and make 2 hydrogen atoms. That gives me 2 chlorines. There's 2 chlorines here, and my calciums are 1 and 1, so now it's balanced. It's just a lot easier to identify where everything went if you write it that way. Yes, if there's a blank, put 1s in them. Yep. No, gives off. Dihydrogen oxide gives off. It just starts with dihydrogen oxide. That's just water, right? It's one of the many ways to write water. That's why we just tell you guys, if it's H2O or HOH, just write water. Okay? You don't have to write hydrogen hydroxide, dihydrogen oxide. It's, yeah. And it actually should be dihydrogen monoxide if you're going to write it that way.